In this lesson, we talk about how generics can eliminate code bloat. The objectives for this lesson are to find out what is a generic, why use generics, and several demonstrations of generics. What is a generic? A generic is a class, a structure, or a method with placeholders for a data type. The placeholder is in the form less than sign t greater than sign, where t is the data type that it's expecting, such as an int, a bool, a decimal, a product. In fact, we saw that in the file system args that we did in the last lesson. So generics, if we think about it, what happened before generics, we would create methods such as get as int, get as string, get as boolean. We would pass something to one of these methods and it would return it as an integer or as a string or as a boolean. So it was a way to convert things. However, with generics, we can create a single method for all of these, and we say get as t, where t is the type, such as int, string, bool. Because if you were to look at all of these types of different methods, you would see they are very similar. The only thing it's doing is changing to different types, int, string, or boolean. So generics are commonly used with collections, and we're going to see examples of that in the next lesson. And Microsoft has a ton of generic methods and collections in .NET. So why use generics? Well, generics eliminate duplicate code, they make our code more reusable, and it enforces type safety. And we're going to see that as we kind of go along here. So you can really see the differences. Let's first take a look at the individual methods like get as string, get as int. Then we'll take a look at the generic version of those. What I've done off camera is I deleted all of the classes from the last lesson and I added a new one called individual methods. Now take a look at the program.cs here. I've got an object value and I've set it equal to dbnull.value. I've then got three console.write lines where within those I do individual methods dot convert to int, the value, comma 0, convert to decimal, value, comma 1, convert to string, value, comma 10. When we run this, we're going to get 0, 1, and 10, because that is the default value that I'm passing in that says if the value cannot be converted to an int, so for example, it's a null or it's a dbnull.value, then use the second parameter. However, if I go ahead and change object value and set it equal to 100, 100 can be converted to an int, it can be converted to a decimal, and can be converted to a string. So that's what we get back. So I have methods, convert to int, convert to decimal, convert to string in this individual methods class. This is a static class with static methods. If we take a look at the public static int convert to int, it's going to accept two values, object value and the int default value. Line 5, I check to see if that value is equal to null or it's equal to dbnull.value. If it is, I return converting to int32 the default value. Otherwise, I return convert to int32 value. Now, I want you to take a look at lines 11 through 16, where I convert to date time. If you look at this, it's exactly the same code other than what? The actual data type. And on the convert class, it's calling a different method. If we then take a look at convert to string, you see it's exactly the same code. It's just the data type is different again. All right, so now we can see that writing all of this code, boy, that's a lot of duplicate code. Let's take a look at how we can solve this problem with generics. So we're going to write the exact same code that you just saw, but we're going to do it using generics, and you're going to see how much less code that you'll need to now write. So once again, off camera, I've added a new class called generic methods. Now let's take a look at how it's used first. So here is our program.cs. Now the first few lines are the same, but now look at the console.write line. We see generic methods.convert to, and that's the same on all three lines now. But then within the less than sign and the greater than sign, I am specifying the actual data type that I want this value to be converted into. And then the second parameter, just like we had before, is the default if it can't convert that. So if we run this, we should get back 100 for all of those because a 100 can be converted into int, decimal, and string. If I make this a db null.value or just a null, then it comes back with those default values. So how does this work? So you remember the old individual methods. Look at how many lines of code there, 38 lines of code. Look at how many lines of code I require now for generics. Only 10. That is huge. So let's take a look at how this works. We have a public static class generic methods. Public static t convert to, and then in the less than greater than sign t, object value, comma, t default value. So what you're seeing here is that everywhere that in the last individual methods class, we saw a data type, we now have t. I still have the same if statement. I'm using a different method of the convert now though, because on the convert, there is a change type method that we can use. And I either convert the default value into that type of t, whatever that is, or I change the value into that type of t. Isn't that nice? I mean, how easy is that? And how much less code? We also now have, type safety. There is so many great things, and you're going to find yourself using generics a lot. Now, it doesn't work just with methods. You can also use generics with classes. Let's take a look. So off camera, I added a storage repository class, and I also added a very simple product class. Well, let's take a look. I've got this program.cs here, and I say storage repository, and then in the less than greater than sign, I do string. Repo equals new, and then I'm setting an entity property. Okay, so let's take a look here. When we run this, what do we get? We simply get this is the data to store. But here's the class. I have a public class called storage repository, but it has to accept a data type, t. Then I can declare a public property using the auto property using public t and call it entity. Then I can have a method, public t insert, where we specify t as entity. We can then assign that to the entity property and then we return it. And in between there, you might store that into some data store somewhere. But there we go. We have a very simple class, but allows us to do this with a string, or we could even use a product. So now you can see that I've got a product class that has a product ID and a name. I fill that in. I use the method insert, right? And it says it's only going to accept. If you hover over this, it actually tells you, look at the IntelliSense there. It says it needs a product object. So it knows that it's a generic and it knows the type and it will give you the correct IntelliSense. Again, very powerful technique here, folks. So this one, if we were to write this out, we can see it gives us back pretty much what we'd expect. Methods, classes can all be made generic. So in this lesson, we saw examples of not using generics, and then we saw how much less code you write by using generics. You're going to use these all the time, folks, trust me. So up next, generic collections provide great features.